In this video, I'll show you how to apply integration by parts more than once. Sometimes you have to apply integration by parts more than once, and this example will demonstrate how it's applicable. Now, some important things you'll need to remember is Lyautey, which stands for the order in which you set your U, and of course, the integration by parts formula. So let's go ahead and start answering this question. If the rate of change of medication in the bloodstream is defined as dA over dt is equal to t to the power of 2 times e to the power of negative t, what is the net change in the amount of medication from time 0 to time 1? So let's go ahead and assign our u and our dv here. Recall that this right here represents algebra and this right here represents exponentials. Take a look at the acronym Lyautey. Exponential gets the least priority, therefore this will be assigned as dv and this will be assigned as u. So let's go ahead and do that. U is equal to t squared, and we're going to take the derivative of both sides, and dv will equal to e to the power of negative t dt. The derivative of the first part will be du is equal to 2t dt, and the integral of the following is v is equal to negative e to the power of negative t. So what we're going to do next is plug this in to our integration by parts formula, which looks like this. uv minus the integral of v times du. And we're going to substitute this value, and this value in here. And don't forget, our question prompts us between 0 and 1, so this is a definite integral. And I do have a video dedicated on definite integrals with integration by parts. So we'll have 0 and 1 here, and also you're going to evaluate this part of the function between 0 and 1. So let's go ahead and do that. Our u value equal to t to the power of 2. Our v equal to negative e to the power of negative t, minus our v once again, which is between 0 and 1, negative e to the power of negative t times du 2t dt. So before we integrate this part right here, I'm going to pull out some loose ends. Notice I can pull out this negative and I can pull out this 2, so let's do that. That'll simplify what we have to do next. Negative t to the power of 2 e to the power of negative t, and if I pull out a negative and a 2, this becomes plus 2, the integral between 0, 1, e negative t times t dt. At this stage of the process, what you would normally have is an integratable function, but unfortunately this cannot easily be integrated. We have to do the integration by parts once again. So we're going to assign this as our u, and we're going to assign this as our dv, and we're going to do the exact same thing as before until it becomes simple. So u is equal to t, and we're going to take the derivative of this. If we do that, we end up du is equal to dt, and dv is equal to e to the power of negative t. E to the power of negative t becomes v is equal to negative e to the power of negative t. So we're going to do the exact same thing once again. I'm going to rewrite everything. And remember, this only pertains to this. So we have negative t to the power of 2 times e to the power of negative t. And we're going to evaluate this between 0 and 1 plus 2. And we will apply all of these to this formula, e to the power of negative t, and du, which is equal to dt. We're going to place this outside because we can, and we end up with negative t e to the power of negative t. These two become plus. This is now integratable. The integral of this is equal to negative e to the power of negative t. And don't forget that both of these will be integrated between 0 and 1. And now we have an expression that could potentially give us the answer. Now, of course, this would require a lot of calculator work. So negative 1 e to the power of negative 1 minus, this all goes to 0 if you apply 0, plus 2 times, you end up with negative e to the power of negative 1 minus e to the power of negative 0. And if we plug this all into our calculator, we end up with negative 0.89. So let's try to interpret this. If the rate of change of medication in the bloodstream is defined as that, what is the net change in the amount of medication from time 0 to 1? The net change will be negative 0.89 units. So there you have it. That is how to apply integration by parts more than once for a definite integral. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.